Hi everybody, this is Mr. Beckstrom, and this week we're going to be going over sections 2.1 and 2.2. So today we'll take a look at quite a few examples and talk a little bit about the concepts of section 2.1. So let's go ahead and first discuss what it means for something to be a function. Maybe you've heard this before, maybe you haven't, but a function is defined in different ways, but visually it means it has to pass what's called the vertical line test. The vertical line test. Let me go ahead and write that out here. So that is the vertical line test. And what does that vertical line test mean? Well, it means that wherever we put a vertical line on this graph, it can only touch up to one point. As soon as we can draw a line that touches two or more points, then this is no longer a function. It's only a function if we can only put lines that touch one point at the most, 0 or 1 point. So what does that mean? Well, let's see. Let's say I just had a point here and a point here, and let's say I had a point here, and I said, is this thing a function? And the answer is yes. And why is it a function? Well, because wherever I put a vertical line here, at most I'm only going through a single point. So even if I put it here, I'm only going through that point right here. If I put the vertical line there, I'm only going through this point right here. And if I go through the vertical line here, I'm going through this point. Now if I do one here, I'm going through no points, and that's fine. If I'm going through here, no points. But at most, not the most, I can only go through I can only go through up to 1 point. I think my recorder is messing up, so I'm going to turn that off. Alright, well, my recorder is acting a little funky right now, so let's just go ahead and finish this up. Alright, so we decided that these 3 points constitutes a function because it passes our vertical line test. Let's say I added a point right here. Would this still be a function? Would these set of 4 points be a function? And the answer is no. Why? Because I can take a straight line right here, and that's going to go through both of those points. And as soon as I can find a vertical line that goes through more than 1 point, this stops being a function. Alright, now let's go ahead and take those points off here and take a look at maybe some curves and kind of try to decide what's going to make a function there. So let's start with a curve that looks like this. And it goes on that way forever and this way forever. Would this curve constitute a function? And the answer would be yes, right? Because no matter where I put this vertical line, at most I can only go through 1 point on that curve. So this would be considered a function. Now it would not be considered a one-to-one function. Why? Because it does fail the horizontal line test. So if I did a horizontal line, and we'll be talking about that later, but a one-to-one function also has to pass the horizontal line test, and you notice that if I put the vertical line anywhere, it's going to go through 2 or more points. Alright, let's take a look at another example here. Let's see if I can get it to draw me a nice circle here. Oops, wrong one. Okay, so how about this? There we go. Is this circle here, would that be considered a function? Alright, and the answer to that is no. Why? Because it fails the vertical line test in a whole bunch of places. It fails here because there's a point there and a point there. It fails here, there's a point there and a point there. So no, this would not be considered a function. Alright, now let's take a look at a few specific examples here. Okay, so this one says here, decide whether the following relation defines y as a function of x. So is this a function? Now, just looking at it, it's pretty hard to tell. Like, I can't look at this and decide whether or not that's a function or not. We have to do a little bit of manipulation. So the first thing I want to do is I want to rewrite this, and I want to convert this from a radical to an exponent number. And the way to do that is if we have an x to the a over b, that's going to be equal to the b root of x to the a. So I can go back and forth between these two, well, the exponent and the radical. So this here is really written as, we can think of that as the 7th root of y to the first. So if you put that over here, our a is going to be 1 and our b is going to be 7. So we can rewrite that as this here. So this is, so x is equal to y to the a over b. So that a over b would be 1 over 7. So these two things are equivalent. The 7th root of y and y to the 1/7. And this is going to be important because now we're going to, what we want to do is we want to solve for y. If we can solve for y, then we can put this in our calculator and we can kind of see if it constitutes a function. But basically what we want to check is that for every value of x, there's only at most one value of y. We can't have more than one value of y. So how do we solve for y here? Well, what I can do here is I can raise both sides to the 7th power. Why? I'm using the word y in two different ways now. Because when we take an exponent raised to an exponent, you multiply them together. And 1/7 times 7 is just 1, so that'll get rid of that 1/7 there. So x to the 7th is equal to y. Now that we have it solved for y, I want to go over to my calculator here. And I want to go to y, and we're going to do x raised, so x raised to the 7th power, which is what this is equivalent to. And let's go ahead and do a zoom standard and see what that looks like. It looks like it's coming up, going this way, and coming up. But it does look like from here that we're definitely passing the vertical line test. It doesn't look like there's anywhere we can put a vertical line that goes through more than one point. If you want to zoom out a little bit, you can do that just to make sure. It doesn't help us too much. You can also go to your window and play around with that. I'm going to take my, this is the viewing window of my graph. Let's go from -4 to +4 instead. So we're going to kind of shrink this thing horizontally, and we'll do a scale of 0.5. This is just something that you'll get used to after a little while. And hit the graph, and that looks a lot neater here, and you can see that definitely passing that vertical line test. So this here is a function. All right, let's go ahead and take a look at another example. Okay, so this next example here says determine the domain and the range of this function here. They call it a relation. It's also a function. Well, we don't actually know if it's a function yet. That's why they call it a relation. But we have y is equal to the square root of x minus 8. So there's different things you can do at first, but one thing that I like to do here is let's go ahead and put that in here. So that's going to be the 2nd square root of x minus 8 of x, and let me clear it out because I still have that to the 7th. 2nd square root of x minus 8. And let's start with a standard. And it looks like we're going to have to move this over to the right a little bit. So I can change my window here. So we're going to start at 0 and go to 20. for my x values. Let's see how that fixes it. And that looks a little bit better here, right? So we can see that this function starts here at 6, 0, and it goes up and to the right. So let's see if we can use that to help answer our problem here. So the domain is all of the possible x values. So far it looks like it's going to be the x values, remember that's along the horizontal bar, is going to be 6 and everything above 6. So our domain is going to be x is greater than or equal to, oops, is that 8? 1, 2, 3, 4, 5, 6, 7, 8. I was saying 6, but this is 8. Excuse me. I don't know why I said 6 there. So this x is greater than or equal to 8. So x can be 8, right? Because if you put an 8 in there, you're going to get the square root of 0, which is 0. But if I try to put something smaller than 8, let's say I try to put 7 in there. 7 minus 8 is -1, and we can't take the square root of -1, at least not in the real world that we're talking about. So this is going to be our domain, because the domain is all of the possible x values in this function here. And graphing really helps me see that. And to write this in interval notation, we're going to start at 8. We're going to put a bracket here because we include the 8 because it can be 8. And then we put a comma, and we're going to go to positive infinity. And infinities always use a parentheses. So I'm going to use a bracket if I include the endpoint there, and then a parenthesis if I don't include the endpoint or if I'm using an infinity. So this would be the domain of the function. Now as far as the range, it looks like going from up and down, it doesn't go below y equals 0 at all. It looks like it starts at y equals 0 and it only goes up. So y is going to be greater than or equal to 0. And we can see that because we're taking a square root, and we can never take a square root and get a negative number, at least not like in the real world. I still have that function on there. Let me turn that ink to shape off. So we can make y as large as we want, so it's going to go all the way from 0 up to infinity. So the range of this is going to start at 0 and go all the way up to positive infinity. And the domain and range are really just saying what x values are in this function and what y values are in this function. All right, let's go ahead and take a look at another example. All right, here we're letting a function, we're calling that function f of x. We're going to let that equal 8x squared plus 9x plus 9. And what they want us to do is they want us to find f of x plus h minus f of x. And this is a really tricky kind of initial subject for people to kind of understand what it means when we have that x there. So if this function is defined for x, then f of x plus h, we're just taking this initial function here, and wherever there's an x, we're going to replace it with an x plus h. And then for f of x, we go, and wherever there's an x, we replace it with an x. So we're going to basically keep that one the same. So let's first define both of these separately, and then we'll find the difference. So what is f of x plus h? Well, what we said was we go to the original function here, which is this, and wherever there's an x, we're going to replace it with an x plus h. So this is going to be equal to x, and replace that x with x plus h, and we have to square it, plus 9, and we're going to replace that x with x plus h, plus h, plus 9. Now let's go ahead and kind of distribute this out and see what we get. So this is going to be 8. I'm going to go ahead and FOIL this x plus h because it's really x plus h times x plus h. So I'm going to get x squared plus 2xh plus h squared plus, and I'm going to distribute this 9 here, so that's going to be 9x plus 9h plus 9. And I can go ahead and distribute this 8 now. So this is going to be 8x squared plus 8 times 2, which is 16, 16xh plus 8h squared plus 9x plus 9h plus 9. Ooh, that's pretty long. And now it says minus f of x. I don't need to do the same thing with f of x because really it's just the same as this. So now let's go ahead and do that difference here. So I'm going to have 8x squared plus 16xh. This is the f of x plus h. Plus 8h squared. Oops. Plus 9x plus 9x plus 9h plus 9h plus 9. Ooh. And this is going to be minus f of x, which is just this. Make sure I put that in parentheses to remember to distribute that negative sign. So that's just going to be 8x squared plus 9x plus 9. Now notice this is going to be a minus 8x squared, so that's going to cancel out with that plus 8x squared. This is going to be a minus 9x, so that's going to cancel out with this plus 9x. And this is going to be a minus times a plus, that's a negative 9, so that'll cancel out with this positive 9. So all of this is going to end up canceling out. So we're just going to be left with 16xh plus 8h squared plus 9h. And this will be our final answer right there. Ooh, that was a yucky one, right? All right, let's go ahead and take a look at one more example from this section here. All right, this one says determine whether the relation is a function. And before we were looking at a curve, but now we're looking at specific points. So what do we want to make sure? Well, just with a kind of a rough graph here, we want to make sure that there's no 2 points on the same vertical line. And another way of saying that is for every x value, there's only one y value, right? So if this x value here was 6, notice that it would have two y values. It might have this one of 1 and maybe this one of 5 here. So in this case here, we would have 2 points. We'd have a 6, 1, and we'd also have a 6, 5, right? And this would not be a function because for the x value of 6, we have two different y values. We have the y value of 1 and we also have the y value of 5. So that's pretty much what I'm going to try to make sure here. And just looking at the first value, for the x value of 3, I have both a y value of 4 and a y value of 3. So automatically just that one vertical line that goes through those 2 points means that this is not a function. So this one here would not, I don't even need to check the rest. Once I find that there's at least 2 points on the same vertical line, I'm done. All right, and let's move on a little bit. All right, so for the next problem here, it says determine the domain and range of the relation. Variables represent real numbers only. So this is going to be x is equal to negative 10y squared. Now, I can already tell you that this is not going to be a function because it fails the vertical line test. Because, for example, if I put a y equal 1, 1 squared is 1, and 1 times negative 10 is negative 10. So that means that x would equal negative 10. So we have the point, oops. We have the point negative 10, 1. And if I put in a negative 1 here for y, so if I put in a negative 1 there for y, negative 1 squared is 1. 1 times negative 10 is negative 10. So I will also get a negative 10 for x. So here we have two of the same x values with different y values, and that means it's not a function. But that's not actually what this is asking. This is asking us to find the domain and the range of this relationship in real numbers only. And another way of saying that is, what are all the x values and what are all the y values? And even another way of thinking about it is, are there any restrictions on what I can put in for x or y? So for example, could I put in a 1000 for y? And the answer is yes, right? There's nothing stopping you from putting a 1000 for y. Now if we looked at that previous one where we had the x minus 8, obviously we could not put in a 100 or a negative 100 for x, because that would give us a negative square root, and that's not in our that's not possible amongst the real numbers there. So since I can put in anything I want for x and anything I want for y, there's nothing stopping me. There's no square roots, there's no denominator. So if I had like 1 over x, I couldn't put a 0 in here because we can't have a 0 in a denominator. There's nothing stopping me from any of those numbers. Therefore the domain and the range is going to be negative infinity to positive infinity for both the domain and the range. We can basically put in any values that we want. And if we were to graph this, we would see that there are values for everything. Now this is not easy to graph in our graphing calculator because we have to solve for y. Let's go ahead and do that. It's going to be a little bit tricky, but just follow me through. So if we start with x is equal to negative 10y squared, I can divide both sides by negative 10, so I get x over negative 10 is equal to y squared. And then if I take the square root of both sides, I'm going to get y is equal to the square root of this, but I have to look at both the positive and the negative of that. So it's going to be plus or minus the square root of x over negative 10. And that means I really have two equations. I have the positive, y is equal to positive square root of x over negative 10, and I have y is equal to negative square root of x over negative 10. So let's go ahead and put both of those in our calculator and see what happens. So y equals, first one we'll do the positives, that's a second square root of x divided by negative 10. And then we'll do the same thing for this one here. We'll do, oops, wrong one. We'll do negative second square root of x divided by negative 10. And let's go ahead and see if we can see what that looks like here. So I'm going to start with the zoom standard here. And it looks like it is a left opening parabola here. Notice that that fails the vertical line test horribly, so we can also see it graphically, but yes, that is done. Alright guys, please let me know if you have any questions. Feel free to either send me an email or post in the forums. Remember, you get extra credit for posting in the forums. And if you have any other concerns, please let me know those as well. I hope everybody has a great rest of your weekend. Thanks.